Understeer, the ultimate betrayal of your front wheels. What is it exactly? It's where your car turns less than the steering angle you apply to your car when approaching a corner. This piece will cover various solutions which you can use in your existing car to reduce this loathsome feeling, whether you are going 10 times in autocross, a racetrack, or even your local roads. We will cover all types of engine placements and drivetrains, ranging from front-wheel drive, rear-wheel drive, and all-wheel drive, and provide solutions with physics explanations. That being said, let's look at the most common layout in automotive manufacturing, FF. From stock, front engine, front wheel drive cars tend to understeer the most out of all the layouts. But why is that? This is as the combination of the engine's weight plus the power being directed to the front wheels means a lot of weight is being pressed down on that tyre. Combined with the front wheels having to turn as well, they can struggle, leading to understeer. Now let's dig deeper. When you initially turn the steering wheel whilst accelerating, Newton's third law comes into play, where each action has an equal and opposite reaction. As the car accelerates forwards, the car suspension will lean backwards, placing more force on the rear tyres than the front, causing understeer due to the front tyres having less grip during the turn. Now that we understand why FF cars tend to understeer, let's introduce some driving techniques to help manage it. One of the simplest methods to reduce understeer is a technique known as lift-off oversteer. When you lift off the throttle mid-corner, a braking force is created that shifts weight back onto the front tyres, where the car's opposite reaction to the lift-off is that suspension leaning forward, shifting the weight back to the front tyre. This increases the grip on the front tyres, reduces oversteer, and in some cases, even causes the rear of the car to rotate more, leading to oversteer. Another technique we can make to our driving style, but slightly more difficult to master, is by trail braking into the corner. As the great racing driver Mario Andretti once said, drivers still think the brakes are for slowing the car down. When you begin initial turning, having braked in a straight line like you normally would before any corner entry, you begin to slightly ease off the brakes. As you steer, you will continue to ease off the brakes until you enter the apex. After you have reached the apex, you begin to gradually accelerate out of the corner. This technique enables 100% of the available grip from all four tyres to be used, allowing the car's nose to rise and smooth weight transfer from front to rear during corner entry and exit. Another method to reduce understeer but safely avoid oversteer is left foot braking, whereas the weight now shifts forward and the increased load on the front tyres will allow them to utilise more grip and now improve that initial turn-in which was so understeer prone in the first place. Left foot braking also provides a more neutral driving style at the limit with its balance between braking and acceleration. We see this technique often used in rallying to manage traction and control the car on loose surfaces. Whilst driving techniques can help, sometimes the car setup will play a big role in understeer. Most stock cars are designed with a tendency to understeer because it's easier to control compared to oversteer, which requires more precision. Let's look at some mods that can help fix this, starting with the simpler ones in terms of assembly. Firstly, you can install a rear sway bar. It stiffens the connection between the rear suspension points, helping reduce body roll during initial turn-in and allowing the rear to rotate more. Of course, upgrading to performance tyres is one of the easiest ways to improve grip and reduce understeer, especially with front-heavy FF cars. Many commuter cars from stock run higher tread tyres, which mean they last longer. They also have thicker sidewalls which cause less grip and stability when entering a corner, inducing these dreaded understeer characteristics. The solution here is going with performance tyres, and whilst they have the drawbacks in things such as longevity, inclement traction, cost, ride comfort, and NVH, there is inevitably increased grip to be had here, especially from the front end, which is inherently robbed of grip during initial turn-in. Low tread wear tyres are characterised by a soft rubber compound, allowing not only quicker heat generation in the tyres, resulting in more grip, but also the front tyres to deform easier to the road surface, where the nose squats down during braking, increasing the contact area between the tyre and the road. Tyres with shorter sidewalls allow the suspension to be stable mid-corner, allowing for better grip during turn-in and corner exit. These thinner sidewalls also allow for less isolation in the steering feedback to the driver, allowing for the driver to make the necessary adjustments when facing understeer. A real-world FF example is from Savage Geese, where in two separate cross-car comparisons at the same Autobahn Country Club South Circuit, they put the same driver in the launch end on two different tyres, which are the Michelin Pilot Sport 4S stock and the Bridgestone Sport on the aftermarket, with the Bridgestone Sport being almost a second faster than the Pi Sport 4S was. Another simple adjustment would be to reduce the front ride height by swapping your front springs with either lowering springs or adjustable coilovers. By lowering the car's center of gravity, there's less weight transfer during cornering, which helps prevent understeer. Lowering front ride height also increases negative camber, by adding negative camber where the top of the tyres lean inward towards the car's centerline by roughly a few degrees, while compensating for the wheels leaning outwards during initial turn-in due to inherent body roll. This is as negative camber ensures the tyre's contact patch remains evenly distributed across the tread, resulting in better front end grip, which is highly critical in an FF car where the front tyres have to play a multitude of roles. The way you can add negative camber will depend on what type of front suspension your car is running from stock. If your FF car has a double wishbone front suspension like the DC2 Integra Type R, which in today's era is quite rare, then you can simply push the upper control arm inwards, having loosened its bolts. Otherwise, your car will probably have a McPherson strut front, and in this case, you would have to use camber bolts. You can replace the upper strut bolts with camber bolts, and dial in negative camber by turning the camber bolts so that the eccentric lobes push the top of the steering knuckles inward towards the vehicle. However, camber bolts typically only allow for roughly 2 degrees max. If you want to dial even more negative camber, as well as quick camber adjustment on the fly, you can use camber plates, which allow for roughly up to 3 degrees max. Whilst the installation process is a little bit more tedious, requiring the complete removal of the front strut to replace the top strut mounts with the camber plates, this allows for negative camber to be dialed in quickly via sliding the plate inwards. A good example is where in 2007, Grassroots Motorsport, in a collaboration with Hotchkiss Tuning, worked on a 2005 Mini Cooper to test the true difference that negative camber makes to one's track times at the streets of Willow Springs, adding a slew of mods including competition camber plates. Fitted with negative 3 degrees of camber, the Mini was 1.2 seconds faster than when it was fitted with a negative degree of camber. Lastly, consider installing a limited slip differential in the front. Before we get into why an LSD is a highly lauded handling mod, let's explain the open differential, installed in the vast majority of cars today. When one wheel loses traction or slips, it will spin freely, whilst the other wheel that has more grip receives less power. During turning, the inside wheel usually spins freely, resulting in nasty understeer due to imbalance in grip. With an LSD, a limited slip effect takes place by allowing for a maximum difference between the rotational speeds of the two wheels. This parameter allows for the LSD to provide more power to the wheel with superior traction and hence preventing the inside wheel from spinning, alleviating this understeer. A great example is when UK's Redline magazine fitted a Quaife LSD on a Clio 200 and shaved 4 seconds of its lap time. Another highly understeer product layout is front engine 4-wheel drive. This is due to 2 reasons. One, whilst a portion of the torque has been transferred to the rear wheels, there is still torque acting on the front wheels, particularly if it is a front biased all-wheel drive system like a Haldex. And combined with the discussion we had in the FF segment, this will induce understeer due to the front wheels' dual duties of managing power, torque and steering. And 2, all-wheel drive systems typically are heavier as they require more parts, and as power is through all 4 wheels, 2 differentials are now required instead of 1, as well as 2 half shafts. Applying some of the solutions already specified for FF, as they commonly share the same corner exit understeer woes due to front heavy similarities, can be a good idea. These can include a rear sway bar to allow for rear end rotation, negative camber adjustments in both the front and rear, stickier tyres, and oversteer inducing driving techniques such as lift off oversteer and trail braking. However, let's examine one of the most iconic driving techniques for reducing understeer, which is commonly used in F4 cars. This is the Scandinavian flick. Used primarily in competitive rallying, this is typically one of the best driving techniques as it allows you to simultaneously reduce understeer during turn-in and maintain a high speed during corner exit. However, it is best used in low grip conditions in tight corners. The idea is to turn the steering wheel in the opposite direction of the corner for a moment, which shifts weight to the outside tyres. Then, quickly turn back in the direction of the corner, causing the rear end to swing out and help rotate the car. As discussed, open differentials on the limit are conducive to understeer, as the uneven torque distribution between inside and outside wheels disables sharp initial turn-in. While some car manufacturers such as Toyota and Subaru have opted to put 2 limited slip differentials in the Halo all-wheel drive vehicles, replacing the rear open differential with an LSD is a sufficient solution for the more thrifty-minded. The reason why replacing only the front open differential with an LSD is not as effective is as it does not mitigate the root cause of understeer in F4 cars, lack of rear grip. The rear LSD will send more torque to the loaded outside rear wheel, reducing the tendency for the front wheels to push wide, as well as inducing a yaw moment, meaning the car will be much more willing to rotate on initial turn-in. Returning to the point made about replacing both open differentials. This is the most comprehensive method to reduce understeer in F4 cars, as the front and rear LSDs can adaptively distribute torque to the wheels with the most grip, which prevents the inside front and rear wheels from spinning freely and helps reduce understeer. The differences between a setup with open differentials and one with two LSDs can be shown via the findings of Australian outlet Motor, where the double LSD equipped GR Yaris Rally, which in Europe is known as the Circuit Pack, was roughly 3.4 seconds faster on the Bryant Park Hill Climb circuit than the non-LSD equipped GR Yaris. Although a few modifications from the base model, such as forged wheels and stickier rubber, also contributed to such a stark difference in times. The second solution we will provide is simply redistributing torque to your rear wheels, if your car allows for this adjustment. The reason for spreading more torque to the rear is as the weight distribution will be improved due to the heavy front end, and more torque to the rear wheels equals more rear grip, allowing the steering to be more responsive to inputs. In the modern era, this can usually be adjusted in your infotainment or by a rotary dial near your handbrake. Toyota, for instance, in a GR Corolla, has a sport mode where 70% of the torque is transferred to the rear wheels, whilst in some all-wheel drive systems such as BMW's X-Drive, and even the late Ford Focus RS in drift mode, you can even distribute all of the elevatable torque to the rear wheels, essentially transforming the car via software into an FR layout, and thus getting the weight distribution closer to the ideal 50-50, which we will discuss in the FR section. Whilst this layout typically yields great balance with short wheelbase cars such as the Mazda MX-5 and Toyota GR86 having an almost 50-50 weight distribution, and with the front wheels only being dedicated to steering duties, understeer typically isn't as much of an issue as the FF and F4 layouts. However, as many rear-wheel drive cars possess long and big engines such as big gnarly V8s like this one and this one, the weight distribution's inherent bias towards the front will always be more likely to understeer, as well as a higher moment of inertia. To reduce understeer, we can apply some of the same driving techniques and modifications. For weight transfer to induce neutrality in the chassis or even oversteer in the front heavy FR, we can use either lift-off oversteer or trail braking. For additional grip and understeer reduction, we can use stickier rubber, reduce front ride height, which allows for a lower center of gravity by eliminating excess body roll, though with negative camber in the rear to improve traction during cornering by keeping those rear tyres more planted, and a rear limb-listed differential to ensure the inside rear wheel is not slipping, and that grip between the two rear wheels is evenly distributed. One of the first mods we will suggest is fitting wider front tyres. As we know, a larger contact patch will mean the rubber can easily deform. When understeer occurs in a situation where we have a front heavy FR, such as a Mustang or a Corvette, this is a great modification to add, allowing improved grip and traction on the front tyres during cornering. A stiffer front anti-roll bar on the chassis underside can also be fitted to increase the roll stiffness of the front suspension, reducing the body roll. The lack of body roll keeps the front tyres more planted and stable on the road, yielding higher grip, traction, and allows us to dial in a better turn-in character. The MR layout is naturally more balanced than the other layouts we have covered, as its mid-engine placement means the weight is now equally spread between front and rear axles, allowing for more neutral handling, uprooted by its advantage of lower moment of inertia. This is a less common layout in the modern world. However, companies such as Chevrolet and Lotus still employ this layout in their Halo, Corvette and the Mira cars. However, under acceleration, the lighter front end can be prone to lift and still yield understeer. To fix this, you can add front aero parts like a splitter or canards to increase downforce on the front tyres, keeping them planted throughout the corner. A rare layout that's only used by Porsche nowadays, this is where the engine is situated between the rear axle and the rear bumper. This is known as the RR layout. This is essentially in theory a very oversteer prone chassis and an exaggeration of the MR layout. However, even more decreased rate over front wheels means, at times, RR cars can understeer out of a corner during acceleration. Similar to the MR layout, the same front aero enhancements can be applied, as well as previously mentioned modifications such as stickier tyres, stiffer front suspension, and a front anti-roll bar can be used, as well as dialing in more negative recamber to prevent snap oversteer. If you made it this far, congrats! In short, every car layout has its own quirks, but there are lots of ways to tackle understeer, whether through driving techniques or car modifications. As technology improves, manufacturers and enthusiasts alike keep finding new ways to make cars handle better. If you've got any other tips or tricks to reduce understeer, drop in the comments. Thanks for watching, I'll see you in a bit.